The Air Force has completed a substantial technical, critical design review of its next-generation B-21 Raider bomber, an aircraft said by developers to mark a new generation in stealth technology able to elude the most advanced air defenses in the world. The review, described by Air Force officials as a key step prior to formal construction of the aircraft, will assess design specs, technology plans, computing power and weapons integration for the new bomber, a platform which service developers say will advance stealth technology itself to new, unprecedented dimensions of technological sophistication. The B-21 program has completed preliminary design review. The next step is critical design review. The Air Force remains confident in the B-21's progress and in delivering this new capability as planned in the mid-2020s, Senior Air Force Public Affairs Director Ann Stefanik told Warrior Maven. Critical reviews of the emerging B-21 design are essential to engineering a platform able to accommodate the most advanced current and anticipated future stealth properties, which include stealth coding and configuration, radar cross-section reduction and heat signature suppression technologies, among other things. A new generation of stealth technology is being pursued with a sense of urgency. In light of rapid global modernization of new Russian and Chinese-built air defense technologies, advances in computer processing, digital networking technology and targeting systems now enable air defenses to detect even stealth aircraft with much greater effectiveness. Russian-built S-300 and S-400 air defense weapons, believed by many to be among the best in the world, are able to use digital technology to network nodes to one another to pass tracking and targeting data across wide swaths of terrain. New air defenses also use advanced command and control technology to detect aircraft across a much wider spectrum of frequencies than previous systems could. This technical trend has ignited global debates about whether stealth technology itself could become obsolete. Not so fast, says a recent Mitchell Institute essay, The Imperative for Stealth, which makes a lengthy case for a continued need for advanced stealth platforms. The essay's principal claim, fortified by lengthy analysis, offers a window of substantial detail into comments from Air Force senior leaders that the B-21 will advance stealth technology such that it will be able to hold any target at risk, anywhere in the world, anytime. The U.S. is now developing its fourth generation of stealth aircraft. The computational capabilities that were available to design the F-117 and B-2 are dwarfed by the power now available to design teams, writes the Mitchell Institute essay, by Maj. Gen. Mark Barrett, USAF, Rhett and Col. Mace Carpenter, USAF, Rhett. Stealth technology works by engineering an aircraft with external contours and heat signatures designed to elude detection from enemy radar systems. The absence of defined edges, noticeable heat emissions, weapons hanging on pylons, or other easily detectable aircraft features means that radar pings can have trouble receiving a return electromagnetic signal, allowing them to identify an approaching bomber. Since the speed of light, electricity, is known, and the time of travel of electromagnetic signals can be determined as well, computer algorithms are then able to determine the precise distance of an enemy object. However, when it comes to stealth aircraft, the return signal may be either non-existent or of an entirely different character than that of an actual aircraft. A stealth aircraft will, for instance, appear in the shape of a bird or insect to an enemy radar. Given the increased threat envelope created by cutting-edge air defenses, and the acknowledgement that stealth aircraft are indeed much more vulnerable than when they first emerged, Air Force developers are increasingly viewing stealth capacity as something which includes a variety of key parameters. This includes not only stealth configuration, IR suppression and radar evading materials, but also other important elements such as electronic warfare, jamming, defenses, operating during adverse weather conditions to lower the acoustic signature and conducting attacks in tandem with other less stealthy aircraft likely to command attention from enemy air defense systems. Given these factors, Air Force developers often refer to stealth configuration itself as merely one arrow in the quiver of approaches needed to defeat modern air defenses. Mixing stealthy aircraft with conventional aircraft deception, air defense suppression, and electronic jamming will complicate an enemy's defensive problem set by an order of magnitude, the paper writes. The authors of the paper explain that newer stealth technology able to outmatch advanced multi-frequency air defenses must utilize a characteristic known as broadband stealth, multi-band or broadband stealth, which is designed to elude both lower-frequency area surveillance radar as well as high-frequency engagement radar, puts an emphasis upon radar cross-section, reducing tailless designs such as that now being envisioned for the B-21.